Hi everyone, today we are going to discuss the different types of functions. Now the three different types of functions that we have are known as the onto functions, one-to-one functions and invertible functions. So these are the three important different types of functions that we have. That is the onto function, one-to-one function and invertible function. The onto function is also known as the surjective function, but more commonly it is known as the onto function. Similarly, the one-to-one functions are also known as injective functions, but again more commonly or generally they are called the one-to-one functions. Then we have the invertible functions, which are also known as the inverse functions or anti-functions, but more commonly or generally we call them invertible functions. Now we will see the onto functions or the surjective function. So what is an onto function or a surjective function? Now if f is a function such that it goes from set A into set B, then I can say that f is an onto function if each element of B is the image of some element of A. Right. Now if f is a function and it goes from set A into set B, then clearly A is the domain here. That means the set A is the domain here and set B is the codomain here. Now we know that in a function the elements of the codomain are mapped with the elements of the codomain. That means the elements of the domain will be assigned some values from the elements of the codomain. Or in simple language, the elements of set A here will be assigned some values from the elements of set B. But as I told you in my previous video when we were discussing functions, that it is necessary that each and every element of set A will be assigned some value from set B. But it is not necessary that each and every element of set B will be assigned as a value to the element of set A, right? But if you want to have an onto function, then this is a compulsion that each and every element of B will be assigned to some or the other element of set A. That means no element of set B will be left out. Each and every element of set B will be assigned as a value to some or the other element of set A. So this is the concept of an onto function. We will see the examples also. This is an onto function or a surjective function, and this is not an onto function, that is this is not a surjective function. So let's see. The element from set A, x is assigned the value 1 from set B. Then y is assigned the value from set B, that is 1. X is assigned a value 1 from set V. Then y from set A is assigned a value 1 from set B. Then z from set A is assigned a value 2 from set B. And w from set A is assigned a value 3 from set B. So here you can clearly see that no element of set B has been left out. All the elements of set B were assigned to some or other element of set A. Like 1 here was assigned to x and y from set A. Then 2 here was assigned to z from set A, and 3 here was assigned to w from set A. Or in other words, 1 is the image of x and y, 2 is the image of z, and 3 is the image of w. Okay, so that means you can clearly see that all the elements of set B have been used here. None of the element from set B has been left out. So we can say that this is a surjective function or an onto function. Now moving on, we will see an example of a function which is not onto or a not surjective function. Now here you can see that again we have the again here in set A we have elements x, y, z and w, and in set B here we have elements 1, 2, 3, 4. Now let's see how the mapping is done here. Now x from set A is assigned the value 1 from set B. Y from set A is also assigned the value 1 from set B. Z from set A is assigned the value 2 from set B. And w from set A is assigned the value 3 from set B. That is, 1 is the image of x and y from set A. 2 is the image of z from set A. 3 is the image of w from set A. But you can clearly see that 4 is not assigned to any element in set A. The element 4 from set B has not been assigned to any element in set A. Or in other words, 4 is not the image of any element in set A. So I can clearly see that 4 has been left out here. But according to an onto function, all the elements of set B must be used in being assigned to some of the element of set A, or all the elements must be an image of some or the other element of set A. But here 4 is not the image of any element from set A, hence this function is not an onto function. Okay, now next category of function we will see, that is the one-to-one function, which is also known as the injective function. So what is the definition of a one-to-one function? Basically, a one-to-one function defines that each element of one set, that is the set A, is mapped with a unique element of another set from set B. Okay, so each and every element of set A will be mapped to a unique element of set B. What do I mean by unique element? By unique element, I mean that no element of set A will be assigned, no two elements from set A will be assigned the same element from set B. Like if I move back, I can clearly see that here x and y both have been assigned the same element 1 from set B. The elements x and y from set A have been assigned the same element 1 from set B. That is, the image of both x and y is 1. So that means both in x and y have been assigned the same element. They have not been assigned a unique element. So this is what I'm talking about. So that means each element from set A must be assigned a unique element from set B. No two elements from set A, no two or more than two elements from set A can have the same image from set B. This is what I mean by unique elements. So here you can see, now we are seeing two examples to differentiate that this is an example of one-to-one function. So that means it must be following the rule that each element of set A is assigned a unique element from set B, or in other words, no element in set A is having the same image from set B. Let's see here. Now 1 from set A is assigned the value A from set B. That means the image of 1 is A. Then 2 from set A is assigned the value B from set B. That means the image of 2 is B here. Then 3 from set A is assigned the value D from set B. That is, the image of 3 is D. Then 4 from set A is assigned the value C from set B. That is, the image of 4 is C. That means all the 4 elements from set A have different images. Image of 1 is A, image of 2 is B, image of C is D, and image of 4 is C. So that means I can say that this is a one-to-one function. But again, this is not an onto function because two elements of B have been left out, E and F. E and F here are not image of any of the element from set A. So two elements of B have been left out. So that means I can say that this is not an onto function, but this is a one-to-one function because each and every element from set A is having a unique image from set B. Now we will now see at an example of a function which is not one-to-one. Okay, so you can see that here 1 from set A is assigned B from set B. Then 2 from set A is again assigned B from set B. That means both 1 and 2 are having the same image. Okay, 3 here is having assigned 3 from set A is assigned C from set B. That means the image of 3 is C here. 4 from set A is assigned D from set B. That means the image of 4 is D here. But in case of 1 and 2, these two separate elements of set A have been assigned the same element from set B. That means both 1 and 2 from set A are having the image B. That means 1 and 2 have not been assigned a unique element from set B. Hence, this is not a one-to-one function. Again, this is not an onto function also, because here also the two elements from E and F have been left out and they have not been assigned as an image to any of the element from set B. So this is not a one-to-one function and this is not an onto function also. So any such function which is not a one-to-one function is called many-to-one. Why many? Because here you can see many elements from set A are having one image from set B. So I can say it many-to-one. So these are the examples of one-to-one functions and function which is not one-to-one. So now the last category of functions is the invertible functions, which are also known as the inverse functions or anti-functions. So what is an invertible function? Okay, invertible function is one which can be reversed, right? I can reverse that function. So basically, what do I mean by reversing the function? That means reversing the order of the mapping. So if there is a function f where the domain is A and the codomain, where the domain is set A and the codomain is set B, that means the elements of set A have been assigned values from the elements of set B. Then the inverse of this function f, denoted by this symbol, by f inverse, will be what? In this case, the domain of f will be the codomain of f will become the domain of f inverse, and the domain of f, that is set A, will become the codomain of f inverse. I will repeat, the domain of f inverse will be the codomain of f. That is, if the if the codomain of f here is B, then the domain, it will become the domain of f inverse, and the domain of f will become the codomain of f inverse. That is, if A here was the domain of function f, then in case of f inverse it will become the codomain. That is, the order of mapping will be reversed. Now here in case of function f, if all the elements of A were assigned the values from the set B, then in case of f inverse, all the elements of B will now be assigned the values from the elements of set A. Or in other words, if in the case of function f, the elements of B were the image of the elements of set A, then in case of f inverse, the elements of set A will become the image of the elements of set B, right? So such a function is known as an invertible function. But we have to keep this thing in mind that not all functions have an inverse. It is not possible to reverse the mapping every time. Every time it is not possible that if there is a mapping from set A to B, then okay, you simply reverse the mapping from set B to A and then it becomes invertible. No, this is not like this. It is not possible to reverse the mapping every time. There are some conditions for the mapping to be reversed. And what are these conditions? A function is invertible if and only if it is both one-to-one and onto. So the previous two functions which we have studied, one-to-one and onto, a function needs to be both these types in order to be an invertible function. That means, first of all the elements from the domain must be assigned a unique element from the codomain, and also all the elements from the codomain must be assigned to some of the other elements of the domain. None of the element from the codomain must be left out. These two conditions must be met. Only then we can say a function is invertible, or only then it is possible to inverse a function. Alright, so if f is a function that goes from set A into set B, right, and then if it is one-to-one and onto, if it is both one-to-one, that means each and every element of set B has, that means if set A represents the domain of function and B represents the codomain of the function, then each and every element from B is assigned to as a value to some of the element of set A. That means it should be one-to-one. And onto, it should be onto also. That means none of the element from set A, none of the element from set A must have the same image from set B, then it will be called onto. So that means this function should be both one-to-one and onto. And if this function f is both one-to-one and onto, that then it will be called a one-to-one correspondence. A function which is both one-to-one and onto is called a one-to-one correspondence between set A and set B. Alright, so here each element of set A will then correspond to each element of set B, and vice versa it will also be possible, because it is not necessary that if each element of set A corresponds to each element of set B, then each element of set B will also correspond to each element of set A if the mapping is reversed. This is possible only when a function f is both one-to-one and onto. That means there is a correspondence, that is there is a one-to-one correspondence between the sets A and set B. Only then the mapping can be reversed. So, for example, now if we consider a function h, I call a function h, and this is the mapping that is defined for the function h. 1 is assigned the value 2. 1 from set A is assigned the value 2 from set B. That means the image of 1 is 2. Then 2 from set A is assigned the value 1 from set B. That means the image of 2 is 1. 3 from set A is assigned the value 2 from set B. Okay, so that means both 1 and 3 are having the same image 2. And 4 from set A is assigned the value 5 from set B. That means the image of 4 is 5. Now as per the rule, a function should be both one-to-one and onto in order to be invertible. But here I can clearly see that this function is not onto, because two elements 1 and 3 are having the same image 2. That means this function is not onto. So that means in that case this function is not invertible. Now let us see if it is invertible or not. That means is it possible to reverse the order of the mapping or not. Now let's see here. If I reverse the mapping, that means if the set B here becomes the domain and set A here becomes the codomain, then is it possible to assign each element of the domain the values from the codomain? Let us see. Now 1 is assigned the value 2 here. You just reverse the mapping, right? You just reverse the domain and codomain. Mapping will remain the same. Mapping will be done in the same manner. What are you just reversing? You are just reversing the codomain and the domain. That means the domain here becomes the codomain here, and the codomain here becomes the domain here, but the mapping will remain same. That means if 1 here is mapped to 2 here, then 1 here also will be mapped to 2 here only, right? Only the domain and the codomain change, mapping remains the same. So this is I call reversing the order of the mapping. So here the mapping was from A to B, and here the mapping is from B to A. That means here you were assigning these elements to set A, the elements of set B as a value to elements of set A, but here you will be assigning the elements of set A as a value to the elements of set B. Now let us see if this is possible or not. 1 is assigned the value 1 from set B is assigned the value 2 from set A. Okay. Then 2 from set A is assigned the value 2 from set B is assigned the value 1 from set A. Fine. 2 again is assigned the value 3. 2 again from set B is assigned the value 3 from set A. Now this is not possible. Why? Because no element can have more than one image. Same element can be assigned as an image to two different elements, which is possible. 2 here was assigned as an image to both 1 and 3. This is possible. But one element cannot have more than one image. This is not possible. Now, when I reverse the order of the mapping, what happens? The image of 2 is 1 and 3. That means 2 is having more than one image, which is not possible in any case. That means this does not satisfy the criteria of the function itself. So I cannot say that h is a function. H is not a function if any element of the domain is having more than one image. That means this is not a function. So it cannot be, it is not an invertible function. When it is not a function, there is no question of invertible or not invertible. So that means if H inverse is not a function, that means H cannot be an invertible function. So you can clearly see here that H inverse is not a function. The inverse of H inverse, which is achieved by reversing the order of the mapping, is not a function, since it does not satisfy the criteria of the function, because the element 2 from the domain is having more than one image, which is 1 and 3, which is not possible in case of a function. So because of this, I can say that the inverse of H is not a function, and we can say that it is not invertible. It is non-invertible, or the inverse of H does not exist. So this is not invertible. So by this you can understand now that when I said that it is not possible that every function is invertible, this is what I meant by it. This is not necessary that when you reverse the mapping, you get a function only. It is possible that when when A is here, when the domain and codomain are reversed and the mapping is then reversed, then the function that you achieve does not satisfy the criteria of the function. So every time it is not possible to reverse the order of the mapping. So every time you cannot have an invertible function. So it is not necessary that all the functions will be invertible. So this was an example where the function h was not invertible. Now let us see at an example of a function which is an invertible function. Now just as I told you that invertible function means if h is a function where the domain is A and codomain is B, then H inverse will be a function where the domain will be B and the codomain will be A. Now let us see that after interchanging the codomain, after reversing the domain and the codomain and then reversing the mapping, do we get an invertible function or not? Now let us again now I'll again remind you the same thing that I told you. To be an invertible function, a function needs to be both one-to-one and onto. Okay. Now here, in case of the function h, one from set A is assigned the value x from set B. That means the image of 1 is x. Then 2 from set A is assigned the value z from set B. That means the image of 2 is z. Then 3 from set A is assigned the value y from set B. That means the image of 3 is y. Now here I can clearly see that each element in set A is assigned a unique element from set B. That means it is an onto function. And also it is an onto function, and also all the elements of set B have been used. None of the element is left out. So it is a one-to-one function also. So that means each element from set A is assigned a unique image. That means it is an one-to-one function, and none of the element of set B have been left out. Hence it is an onto function. So it is both onto and one-to-one. So that means according to this definition, the inverse of H must exist, or H must be an invertible function. Now let us see. I make the domain here the codomain. Now in case of H inverse, as per the definition, A will become the codomain and B will become the domain. Okay. So the elements of B will come on this side and the elements of A will come on this side. Now the elements of B will be assigned the values from the elements of set A, or in other words, the elements of A will be the image of elements of set B. Now here x mapping remains the same. X was assigned to 1, so here 1 will be assigned to x. The mapping or the correspondence will remain the same, only the domain and the codomain are changing. So here 1 was assigned x, so we reverse that. Here x was assigned 1, so we reverse that, and 1 is assigned to x. Then here y was assigned to 3, we reverse that, 3 is assigned to y. Here 2 was assigned z, we reverse that, here z was assigned to 2, we reverse that, so 2 is assigned to z. That means here x was the image of 1, here 1 became the image of x. Here z was the image of 2, so here 2 became the image of z. Here y is the image of 3, so here 3 becomes the image of y. The correspondence, the way in which elements are mapped is same, only the order of the mapping is reversed. But that is possible after reversing it also, right? So x is having assigned a unique element, y is assigned a unique element, z is also assigned a unique element. That means it is an onto mapping. Then each and every element of the codomain is being used in assigning a value to the elements of the domain. That means it is one to one also. So I can clearly see that this satisfies all the criteria of a function. That means after inverting h, even then I get a function which satisfies all the criteria of a function. Hence, that means I can say that the inverse of h exists, and hence h is invertible function. So this is the concept of an invertible function. And so these are the three different type of functions that I have. That is the onto function, the one-to-one function, and the invertible function.